I know sounds like we only got a couple individuals on today, which is fine. If anybody joins coming in to the call, perfectly fine. We're excited to present to you guys today the best practices for tax measures for financial reporting. It's going to be presented by one of our consultants here at Collectiv. His name is Grant Lewis. Grant's on the call. His video's off. He's got a little bit of internet connection issues today, which is perfectly fine. We all kind of run into that stuff working from home anymore. We also got another one of our consultants on the line as well, Dennis Carrier. So looking forward to presenting to everyone on the call today what we have going on here. So that said, just a little bit about Collectiv. So we are a strategy and data analytics consulting firm based in Chicago, Illinois. However, we have consultants located all across North America. That includes US and Canada. We specialize within the Microsoft data stack. So we are only focusing within the Microsoft data stack, and then we specialize in the Power Platform, which includes Power BI, which we'll be talking about today, Power Apps, and also Power Automate. And the other thing that encompasses that, so when we talk about the Microsoft data stack, is also Azure. So we're talking about Azure as far as data concerned, is anything to store your data, move your data, transform your data. So anything data related, so it can be anything like an Azure Data Lake, SQL storage, blob storage, moving our data using things like Azure Data Factory, data warehousing using tools like Azure Synapse. So all of those things are areas that we specialize in, and we help organizations all the way from strategy to implementation to support. Strategy meaning, if you have a Power BI initiative going on, or if you want to implement Power BI, but you're really not sure how to get started, maybe you have some issues with data governance, adoption, all of these things. That's really all things that are important to rolling out a proper Power BI implementation throughout your organization. Then obviously implementations, that's as simple as it sounds. Maybe you've identified 5 or 10 reports you need to implement or replicate from one system to the other. That's what implementation is. Maybe that's a data warehouse or data infrastructure you also need to implement. Those are all things that we help our clients with. And then last but not least, the support. And support can be really, it's sometimes if you just need to get going with a project, but you don't want to actually put a project in play, that's how support can come in. If you need an extended, business intelligence arm that maybe your firm can't handle, we also help with that. And so a lot of that is post-project support or Power BI training, Power Apps training, et cetera. So all those things can be handled through our support plan. But that being said, enough about Collectiv. Like I said, we can help you with all of those different areas. So if your firm or you are needing some help, please reach out to us. We're happy to help in any way, shape, or form we can. But today, I want to hand it over to Grant, who's going to be teaching us about best practice DAX measures for financial reporting. And as always, if any of you have questions during this, please put something in the chat. It's a pretty small group today. Just let us know what questions you have, and we'll come off mute and we'll help you out with your DAX issues. So that said, Grant, I'm going to hand it over to you and let you take it away.
All right. Sounds good, Greg. Thank you for the introduction. Just getting ready to share my screen now. Short introduction. My name is Grant Lewis. I'm an analytics consultant at Collectiv. I've been working with Power BI for close to 4 years now and been with Collectiv for about a year. I thought it would be good to start out with common financial reporting metrics and use cases. So when I think of financial reporting, I think of a lot of ratios and variances to prior periods, such as like variance to previous year, percent change from previous year, category percentage of total, and then month over month variance, stuff like that. And so I've put together a list of DAX measures that I think are very helpful when working with financial reporting. Although some of them seem a little basic, there's all very powerful functions that you can do a lot more with than I'm going to show just in this presentation. And then feel free to ask questions throughout. It's a pretty small group. If you have any questions or want anything clarified, don't hesitate to ask. So moving on to the DAX measures that I will be covering today. First, we're going to go through just a brief overview of date and time functions such as calendar and calendar auto. Then we'll move on to filter functions such as calculate, all, and selected value. We'll touch on time intelligence functions such as same period last year, dates and period, dates between, and then the dates year to date, quarter to date, and month to date, and explain the differences between the different functions. We'll also touch on the switch function as well as aggregate functions such as SumX, AverageX, and distinct count. So I will start moving over to Power BI. So financial reporting, the base and fundamentals really come down to first a date table in your Power BI report. Every report should have a date table, whether or not you explicitly use time intelligence calculations. It's the base of pretty much all financial reporting is being able to look at these metrics over a period of time, because looking at the metrics themselves without any sort of comparison period or trend is not very useful. And so if you don't have a calendar table already in your database or Excel file, you can easily create one in Power BI using either the calendar or calendar auto functions. So I will quick go over each and discuss the differences between the two. So for the calendar function, you can specify your start and end date. This is probably the one I use more often, just being able to set the dates yourself, whereas calendar auto scans your data and gives you a date table with continuous dates from the data that it's scanned. So it's only going to do that range that it automatically found, whereas with calendar, you can specify the range that you want. And so you can build off these columns because these just produce date columns. And so you can build off of that by doing month and year formulas from the date column to build out your calendar table and make it more robust, giving you more fields to slice and dice with and view your data by. Now that we've covered sort of that very fundamental piece of financial reporting, I wanted to touch on another very fundamental piece, which is the calculate function. It is one of the more simple yet very, very complex functions of Power BI. It's very easy to learn, but somewhat hard to master. It's a very powerful function that allows you to calculate any measure with a given filter context. So as you can see over here, we have the total sales measure, but looking at the data, what if I wanted the sales of just shipped orders? Or if I wanted the sales of just classic cars? We can easily do that using calculate. And then we'll do our measure total sales. Then the second part of the function takes an argument for the filter context that you want to apply. Sometimes you will have to use the explicit filter function if you're filtering more than one column. But if you're just filtering with one column, you can just do a direct mention like this, where you go to product line and then equals classic cars. This will give you the sales of only classic cars. So this is obviously a very, very basic example, and you can build out these calculate statements to have multiple filter contexts and can really make them into be a really specific, powerful function. And I would say that calculate is probably the single most used function, at least in my experience. Another great thing about calculate is that it can be used with other filter functions functions such as all and all except. All plays a great role in taking parts of a whole. And so we'll throw on some dimensions here like country, and then we'll do year here in the columns. And say for total sales, we'll throw that in there. You wanted to see, so what percentage does each country make up of the total sales for this year? And when you calculate percentages in Power BI, you have to be very, very careful, because although your equation itself might not have filter context, so total sales does not have filter context, it's just a simple sum equation, but there is filter context introduced by the matrix here, specifically with country and year, that automatically filters that measure. And so you want to make sure that you're dividing by the correct thing. And so for the percentage of the whole, we want to see what percentage did each country make up of the sales. And so to get the denominator of that equation, we will introduce calculate with all. So we'll do country all sales. Use the calculate function again, total sales. And then here, we will use the all function, which removes all filters for that column. So we will do all country and close this. So then in this table, you can see that it has the same value for every single row, which is...
Looks like we might be getting Grant back.
Hey, Dennis. Yeah, sorry, I'm having some network issues right now. I can continue to present, at least if my computer will let me.
Sure.
So for here, real quick before my Wi-Fi unfortunately dropped, we were discussing how the all function just gives you the grand total for each row, which is great because we want the parts of a whole. And so to make this calculation, like round things out, we are going to create a new measure. And we're going to do country percent of whole. And then one other thing I wanted to touch on, I didn't want to go over any super basic arithmetic functions. However, I think it's important to note that when it comes to dividing in Power BI, if you are dividing a measure by a constant, such as like you want to convert something to a different unit, if you're dividing a measure by 100, you don't need to use the divide measure. You can if you want. But the divide measure is really important when you're dividing two measures. It just helps you clean things up and make sure that you get the correct answer every time. And so here we are going to do total sales, the numerator, the first column for each country, looking at parts of the whole. And then we are going to do the country all sales here with 0 as the alternate result. When it comes to adding the alternate result, I think that it's important to always add 0, just because I can't tell you how many times it just ends in an error and looks a little sloppy in the report. And so we'll remove or actually, no, we'll just keep it in. So I'll change this to %. And so now all of these countries show their percentage of the whole, and they add up to the correct 100% at the bottom. The subtotaling being correct is one of the most important reasons why you want to use all, just to ensure that you're getting the correct denominator and the filter context is not interfering with your ratio calculation. So now that we have touched on that, One of the other filter functions I wanted to go over was another simple one, but it's very, very helpful. So here we'll add in a slicer, and we'll go here to put calendar year in. Get rid of this, and we'll just leave total sales in there. So selected value is a really helpful function because you can reference the value selected in a slicer, or even selected value applies to which row you're currently in a matrix or another filter context. And so I have total sales right here. And this isn't very helpful because it's just the sales all together. There's nothing splitting it up except for country. And so we don't really have any timeline for these sales. Where you can use selected value is you can go here and do a calculate function. And we'll do calculate total sales. Then we'll do year in the fact table equals selected value, and then calendar year. So what that does is that filters the year in the fact table, table sales year, to the selected value of calendar year. And so we'll throw that into the matrix here. And so it's going to be blank right now because there is nothing selected. And then we will do a drop down and change that to 2019. So as you can see, these are exactly the same. However, this selected value function allows this to dynamically filter to whatever year you've selected. And this is just a very, very basic example of this function and all that you can accomplish with this. I've had a use before where I was building out a dashboard for a client and they only had 1 year slicer. They wanted to choose 2 years in a slicer to compare the two and have all the visuals dynamically changed to show the comparison between those 2 years that they had selected, but they only wanted 1 year slicer. And so working some magic with a selected value, I made it so that you can select 2 years in one slicer, say for instance 2020 and 2018, and it will take the latest year automatically by using the max function, and it would compare it to the lowest year selected in the slicer, which was whatever other selection that they had made. And they had cards with ratios on them, and they would all change to reflect that percent change year over year with those 2 years that they had selected. So the selected value function really does add a lot of value to the calculate function and allows you to build more robust reports and reference specific values selected in slicers. So now that we've covered those, I wanted to go in a little bit more to time intelligence functions. So one of the most helpful that I find is we'll take selected, or we'll do the total sales here and throw calendar year in there. I find that one function that's really helpful for ratios and year over year comparison is same period last year. So we'll just get 2 years in here, make it a little bit simpler. And so say, for instance, we have 2019 here, but we also want sales for 2018. You can use these sales or same period last year measure and this measure will give you the current dates shifted back 1 year from the selected period. And it is essentially the same as doing a date add minus 1 year. So we'll select the calendar dates. And we'll throw that in there. And so for 2019, as you can see, the same period last year gives us the results for 2018. This is still a very basic example and doesn't really show the full functionality of this function. However, it is very useful when computing ratios. Year-over-year change is a big one. It just makes things a lot simpler, and it's a pretty simple function to use while giving you this result. Another time intelligence function that I thought would be important to mention is dates in period. I think dates in period is very useful just because you can do relative dates. And so say, for instance, you wanted to view sales over the past 6 months from your current day, but you didn't want to explicitly write the end date for that period and you wanted it to be dynamic. This is where dates in period would come into play. So what you will do is make a calculate statement, total sales, and then we'll do dates and period. Here it's going to ask for a date column. And then for start date, we could choose any date we wanted, really. So if we wanted, we could do the minimum date in the date table or the fact table, and then we can shift that any number of intervals forward or backwards, the negative sign in front of the number to denote going back in time. And then we get to select the interval, which can be, I believe, either day, quarter, or day, month, quarter, or year. And so in the future, or in the past, I have done different versions of this. So for a client, they asked to view their forecast data for the next 6 months. And so how we would accomplish that is we'll calculate the forecast column or the forecast measure, and then we'll use dates and period with calendar date. And then we would do enter 6 for the next 6 months and then denote month here. Okay, so this is it's just any start date you want, shift it. We could do today and then shifted 6 months forward, and then it'll give us the option to do month here. And then this will give you your total sales value over the next 6 months. And so that is dates and period is really helpful for relative ranges, such as just 6 months from today, dynamically. Whereas another version is dates and period, or dates between, where dates between is more for explicit date ranges. And as you can see, almost all of these functions that I'm doing start with calculate. It is probably the single most important function in Power BI, and definitely one you need to master if you are going to do financial reporting. Then we can select our calendar date again. Then it gives you a specific start date and end date, which you can choose to be whichever you want. Say, for instance, we could do the minimum date in the date table and then go to the max date. or any sort of interval between there, but you just have to explicitly state the start and end date. And so that is why dates between and dates in period are different. Other one I wanted to touch on was the dates year to date, quarter to date, and month to date. So we could do sales year to date. I know that a lot of fiscal calendars are different than calendar years. And so it's not always easy to calculate year to date values, but the dates year to date function makes that very easy. So you could go to do calculate sales again, and then dates year to date. And then you're going to enter your date column again. And then there's an optional argument at the end that returns a year end date. So say our fiscal year ended May 31st. I'm going to calculate all sales between June and May 31st and be dynamic for each year. So if I threw this into this matrix, these will only be values from June to May 31st. So the year to date is going to be that fiscal year that we specified. And then the other versions of that function are doing quarter to date or month to date. All are probably equally as helpful. I just think it's a very easy way to do those year to date or month to date calculations without a lot of thinking involved. So from there, I want to move on to another function that I think is extremely helpful. I use it on a regular basis, which is the switch function. So the switch function is great for multiple reasons. One that comes to mind that I have to do very regularly, I would say at least once a week, is so say, for instance, you have these product lines and you wanted to assign a number value to them to sort them in a specific order. This is where the switch function is very helpful. So you can see here we have classic cars, motorcycles, planes, and say, for instance, we just wanted to have classic cars be 1, motorcycles 2, planes 3, and then we didn't care about the rest of them. So you could do a new column here. So we will do product sort order. We'll do the switch function. And so here you can enter the column, product line, and then we'll do the first value, which would be classic cars, and we'll assign that a 1. Then another motorcycles, 2, and then planes. And then we'll just have it return blank for the rest. And so what this is going to do is it provides, or it gives you a 1, 2, and 3 for each of these values, making it very, very easy to do a sort by column. So that is one thing that I have to do on a regular basis for my job, is sort a column by another column. And so you need obviously a column with 1 value for each of these. And so it's going to sort it either, or no, it's going to sort it by 1, 2, 3. It's going to sort ascending. And so that is one use for the switch function. Another that I think is helpful is there was this client that had asked me to create a slicer that's you selected a measure from. And so this is helpful because they had numerous slicers up here and they didn't want to crowd the page with multiple visuals. They just had one big matrix with year and period on top and employee name on the side. And they wanted to be able to switch between, I believe it was 4 to 5 measures to where they wouldn't have to leave the page and you wouldn't have to have multiple visuals on one page. And so we can also do that. I can quick do that example. So to do what I am talking about, we'll go to measure up here, and then we'll do total sales, total budget, then sales last year. And then here we can assign them a sort. And so this table will be loaded into the model. And then what we can do here is, once that is up, we'll throw some periods in here and we'll go back to country. And so now that we have that built, we can make another measure. We'll go up here, create the measure. And so we'll do measure selection, and then calculate again. Actually, no, it'll be switch. And then we'll do selected value. And the measure we're selecting. And so if that is total sales, you're going to return total sales. And then if it's total budget, total budget, and then for sales last year, and get rid of this. Then again, we can just do blank if nothing is selected. And so what we're going to do is we're going to throw this measure into here. And of course, it's going to be blank at first. There's nothing selected, but we can make a slicer. We'll throw in the measure from the measure selection table. And so here we'll have total sales, and then it will automatically show total sales from that one measure, but you can also switch to total budget or sales last year. And so I think that that's a cool implementation of the switch formula, just being able to dynamically switch between measures without having to take up this like precious white space. Report pages can become crowded very easily, and especially if you have multiple visuals that only really showcase one metric, it's a little difficult because you don't want to have 10 pages down here and a bunch of different visuals on every page. And so this is kind of a cool way to consolidate those measures and a very like practical use for the switch formula. So now that we've discussed the switch formula, I want to pivot again to going over some of the aggregation functions. So the first one I will discuss is SUMX. So SUMX is different than sum because SUMX completes the calculation within the bounds of the equation, and it iterates at a row level. So if you were to do total sales, it's just going to be the sum of this sales column right here. But say, for instance, you didn't have this sales column and you needed to compute the total sales, but you didn't just want the total number, you wanted it for each transaction. How much did order number 10161 bring in for sales? And so an easy way you can do that without adding a calculated column, I would try to stray away from calculated columns as much as you can, because they take up a lot of RAM and processing time in your model. And if you can put something in a measure rather than a calculated column, I would definitely go that route. And so if I wanted to get the total sales value for that order for each row, I would go here to create a measure. And so we'll do SumX sales, SumX, and here it's going to ask for a table. So you can reference a specific table like this, or you can use this in tandem with the summarize function, which summarize creates a virtual table that you can enter for this table argument here. That's a little bit out of the scope of what I wanted to talk about, but SumX can become a lot more powerful when used with summarize and other virtual tables. And so we're going to enter that table argument there, and then we want the units, or no, we want the total sales dollars. And so we wanted to do quantity ordered multiplied by the price. And so what this is going to do, so if we throw it in the visual here, we'll do the original total sales, and then we'll do SumX sales. So this will calculate it calculates the sales value for every single one of these rows. So every single order, it will go through and do 34 times 1500 for each of them. It would be just like a calculated column, except it does it all within the bounds of the measure. And so SumX and other iterator functions are a great tool to help clean up your model and optimize it a little bit more. Another one that I wanted to discuss was average X. And so with average X, I'm sure you can kind of tell what it does. It has the same concept that SumX does, except it would take an average. And it would do, so if we wanted to do this average X, and one thing that I think is very helpful is that it doesn't have to be a full table argument that you enter. It can be one column. And so you need to return a scalar value. And so we will enter the customer name column here. And then we'll do total sales. And so what this is going to do is it will go through and automatically compute the average amount of sales per customer that you have. And so the iterator functions are extremely helpful, and you can really manipulate these to make it whatever you want. One of the most helpful things that I think is a benefit of the iterator functions is that you can make it the subset of data that you want to perform the action over, really anything you want. You can list out, with summarize, you can list out different group by columns that you want to view the data by, and then surround it with an average X or SumX, and that will compute a table calculation and your data that's grouped all within the bounds of this one measure. And that's why these measures are so powerful. The last function I wanted to touch on was a relatively simple one, but also very helpful, and one that I use on a regular basis. So say, for instance, you wanted to get the total number of orders you had, but you only want distinct orders. And so I think distinct count is a very useful function. Whereas if you were to do a count of all the rows, it would provide you many, many duplicates for each order, whereas distinct count can give you the number of orders. And so it's very helpful for tracking things such as like invoice numbers or order numbers, things that you only want to count once. And yeah, I just think it's a very useful calculation. It might be simple, but it provides value when used in a report. And it's definitely a very useful tool for financial reporting. So those are all the functions that I had prepared today to talk about. And so now I kind of want to open the floor if anyone has questions about anything I went over, or if you are wondering about other functions or wanted me to cover something else real quick, feel free to ask.
Hey, Grant, I was wondering if you could go into creating your date table a little bit more. I know you showed them how to basically create the date and then build off of that. I was wondering if you could show how to create the month, the year, and the week, and the different versions of months, so you have something to sort by as well. I think
Sure.
most of these calculations you could see are really basing off of your date table. So it's important to have one that encompasses all of the different types of logic that you're trying to create within the report.
Sure. Yeah. So to create this date table, we will go new table. And the functions I went over before are the calendar and calendar auto. I will just use the calendar one here. So we'll do calendar. We'll make the start date January 1st of 2018. Then we'll make the end date December 31st of 2021. And so now, as you see, we have a new date table, and it only has this date column. And so what Dennis was talking about was we'll go here to create a new column, and we'll make this one year. And so it's very simple. You just use the year function and then use your date column. And there it will provide a year for every date. And so it's just a way to slice your data more and build out this table. And so we can do the same thing for month. We'll go here, do month. And I believe you can go through and do like day, week, really anything you want to do with these date tables. And so now we have year, month, and date. One thing that I think is important to mention is that month, when you add it, it's always going to be the number value. And so a way to do that would be, we'll go here. We'll do format. And we'll do month. Add value to get the long name. So I believe that these should Yep, it will provide the name of the month for those different months that you have in there, and you can change it to anything you want. Really, you can if you want it abbreviated to only 3 letters, or the short version of the month, you could change this to only do 3 M's instead of 4. And so this is really just scratching the surface of how robust you can make your date table. I've had people add in columns for signifying whether it's a weekday or not, or obviously which quarter, financial period or fiscal period, really anything you want. But like Dennis was saying, the calendar table is the single most important table in any sort of financial report. You absolutely need one, especially if you're doing any sort of time intelligence calculations, because you can calculate all the metrics you want and have pretty complex measures. But if it doesn't have a time period to be mapped against, it doesn't end up being very complex or helpful in the end. And so that is why date tables are so important. And like I said, if you don't have one already in your database, it's very easy to just make your own. So are there any other questions?
Yeah, there's another question in the chat. What do you use as a networking days replacement in BI?
Networking days?
Yes.
So that can kind of go back to what I just mentioned about doing the weekday indicator. So you can make a function to look at and see whether a day based on the date column is a weekday or not. And then really simple way is if it's a weekday, you can use the switch function to have it just be equal to 1. And then if it's not a weekday, you can have it be equal to 0. And so to get net working days, you could just create that column and then sum that column. And then you'll have your net working days relatively easily. Are there any other questions?
All right. Well, if there's any other questions, speak. Otherwise, we will go ahead and conclude today's session. Appreciate everybody who joined. Especially appreciate Grant for joining and Dennis for helping out as well. And then also Simi for hosting on the marketing side here at Collectiv. So again, thanks everybody for joining. We'll have another one of these at the beginning of December. So looking forward to seeing everyone there.